Okay, in Year 12, perhaps the most basic thing you needed to know with naming was just how they went in terms of number of carbons. If you have one carbon, for instance, and this is the alkane group, so they end in ane, they've only got hydrogens attached to them. It was methane. That prefix for meth was for 1. When we went up to 2 carbons, it went to ethane. And again, the suffix there was for the alkane. 3 carbons we went to propane. It's got 3 carbons. And as we go up, now to stop drawing the structural formula for these, you should have some idea of how to do it, but this goes to 4 carbons, 5 carbons for pentane, 4 carbons was for butane, 5 carbons was for pentane, 6 carbons is hexane, 7 carbons is heptane, and 8 carbons is octane. Okay, remembering if I was to, for instance, draw the structure of heptane, I'd do 7 carbons in a row, connecting them with a single bond, 3, 4, 5, 6, 7. Now each carbon has to have 4 bonds around it. Now with alkanes, they only have hydrogens around them, so you kind of get used to counting to 4 in carbon chemistry, because the carbon atom can have only 4 bonds around it. So if I draw in the H's here, and around every carbon you'll notice there's going to be 4 bonds. Obviously the bond between each carbon counts as 1 bond. It's a single bond. Okay, so that would be heptane. That's the most basic thing. Now you can have side groups coming off the main chain, and we have, for instance, a chain here which has got 1, 2, 3, 4. Now I've deliberately left off any other atoms just to show that this carbon here is coming off it. Now if there's one carbon coming off, it might have just 3 H's attached to it. This side group is known as a methyl group. Okay, and you can denote it as CH3 if you draw it structurally, because this is a structural formula. We have those little sticks. That's how that would appear. Now if you had a longer side group, an extra carbon, it would go to be called an ethyl group. This is what it would look as a condensed formula, and this is what it would look like if I drew it out structurally. Now you can keep on going with side groups as they get bigger and bigger, and the group would be propyl, and then butyl, and then pentyl, and then hexyl, and that's how we name them. That's why these are called acyl groups. Okay, they're not a full chain, they're an alkane type chain that's coming off a main chain. Okay, so that's kind of important to know. Now if we were asked to name this structure, first of all we'd identify, are there any other functional groups? Are there any chlorines or bromines attached to it? Are there double bonds attached to it? Does it have an alcohol group attached to it in any way? Does it have anything else? Now in this case obviously we have nothing else, so this is an alkane. Okay, so first of all we identify the longest chain and we just count that. So it's going to be 1, 2, 3, 4, 5. So it's going to be pentane, because there's 5 carbons. Now we have this group coming off it. Now that side group is known as a methyl group. So we have to assign a number to that. That's the lowest possible number. Now if we were to call it 4-methyl, that wouldn't be the lowest number, because we can actually count these carbons from this side as well. 1, 2, 3, 4, 5. So we give a number that's the lowest one, which is why we're going to call this 2. You place a dash between numbers and words. 2-methyl pentane. That's how we would number that. Okay, how would we name this? Well, again, we have nothing like halogens or double bonds attached to it, so we're just looking at the fact that all we've got is carbons and hydrogens. So this is an alkane. There are no double bonds or triple bonds. So we look for the longest chain. There's 1, 2, 3, 4, 5, 6. So the longest chain is hexane. So you kind of get used to going from the right to the left in terms of writing the name. Okay, we have a methyl group here and here. Now if we number it from the left, that would give this methyl group the number 2 and this one the number 3. If we were to number from this side, the numbers would be higher because it would be 1, 2, 3, 4. Now there's 2 of them, and we have a special prefix that we use for that, and that's di. Di equals 2 and tri equals 3. So this would be 2, 3. Now the 2 refers to the carbon it's attached to, and we have to say where the other methyl is because it could be in a different place, and we put a dash, and that's dimethyl hexane. Okay, now this is a similar case. If we count them, we've got 1, 2, 3, 4, 5, 6. So the longest chain is 7, so it's going to be heptane. Now we have a methyl group here and here, and that's on the number 2, that's on the 2, 3, 4, 5, 6, 1, 2. So it doesn't matter which way we count this, either the right or the left is going to give the same number. So we're just going to write that down as 2, 6 dimethyl heptane, and that's that one. Okay, if we look at this one, it's a little bit more complex, or so it seems. So if we're counting the longest chain, we could count it like this. We go 1, 2, 3, 4. Now if we went down here, that would be 5, 6. And if we went across here, that would also be 5, 6. So it doesn't really matter which way we count this, as long as we're systematic. So I'm going to take off this one down here and there, because it's not going to change it. That means the longest chain is going to be hexane. But that means we now have a side group, which is this one, because when you're counting the longest chain, which we did going this way, you cannot go back on yourself and go 1, 2, 3, 4, 5, 6, and then go 7, 8, 9, 10. Okay, so that's hexane, and we have a side group. Now if we were to say it's on the number 4, that wouldn't be giving the lowest number. If we count from this side, it's 1, 2, 3. And this group isn't a methyl, it's a ethyl. So that would be 3 ethyl hexane. Okay? And that's that one named. Okay, now this one we actually have something a little different. We've got a chlorine here, and that makes this a haloalkane. So the halogen is what we're interested in. And that's on this carbon here, which we'll call the first carbon. But there's 3 carbons, so it's propane still. And there's a chlorine on the number 1 carbon here. So we have 1, 2, 3. So that's 1 chloropropane. Now if we look at this molecule, again we notice that there's a bromine there, but we also notice a methyl group there. Now as a methyl group is only carbons and hydrogens, we don't consider it the most important atom or group, because this is here is what we call a functional group, and the functional group is haloalkanes. So if we're going to count, we count from this side, and we must include the functional group. 1, 2, 3, 4, 5, 6. So the longest chain again is hexane. We've got a bromine atom on the number 2, so that becomes 2-bromo. And we've also got a methyl group, and it's on the number 5. Now we don't count from this side and go 1, 2, because we've already started counting from this side, and we've named the bromine number 2 correctly, because the bromine is what we consider the most important, and it gets the lowest number. So we've got a methyl group on the number 5. Now how you write this is you do it in alphabetical order. So the bromine comes before M, so it's 2 bromo dash 5 methyl hexane, and that's that one named. Okay, now how do we name this one? Well, we notice one thing. We've got a double bond here, and that makes this an alkene. So that means the suffix is going to change to "ene" on our naming. So what's the longest chain here? Well, if we count them, we can start with 1, and we want to give the double bond the lowest possible number. 1, 2, 3, 4. Now we could go 5 here, or we could go 5 here. It doesn't make any difference. So it's going to be called pentene. Now we've got to say where the double bond is, and the double bond's between the number 1 and 2. So we give it the lowest number, which of course is 1, not 2. It's 1. So we can write that as pent-1ene, which is my personal preference. That's the number 1 there. Or we could write it as 1-pentene like this. I'm going to stick with the top one. And then we've got a methyl group on the number 4. So that's 4-methyl-pent-1ene. Okay, and that's that one named. Okay, now looking at this one brings out a number of things. A, it is an alkene. We can see the double bond there, but we can also see the chlorine here. Now just one thing, it doesn't actually matter if I'd put the chlorine here or if I'd put it on the other side over here, because single bonds can rotate freely. That means this can move from this position to that position and back again, and in fact they do. So it doesn't really matter where I place them, just the same as these hydrogens. It doesn't matter what position they're in. Okay? Double bonds do stop rotation, so it's not quite true for this one, but just so you have some idea about placing these and what matters. Anyway, in terms of naming this now, we've got 1, 2, 3, 4, 5. If we number it from that side, if we were to number it from this side, it'd be 1, 2, 3, 4, 5. So the number that's going to be the lowest is 2. So that's going to be pent-2ene. Now notice I kind of ignored the chlorine. Now this is one of those things that we call precedence. Which is the most important thing here? The most important thing here isn't the chlorine, it's the double bond. The double bond determines a more important reactions that this molecule can do. So that means even though we could have given the chlorine a number 2, we don't. We give the double bond precedence, and that means the chlorine is going to be on the number 4. Okay, so it's 4-chloro-pent-2ene. Now don't get too concerned about precedence and what comes first. This does become obvious, and there's only a few examples to remember.